For those of you who don't know me, I'm Charlie. I run an ISP in Edinburgh called Fluency. We are a business-based ISP, and we have recently done a bit of LLU in some exchanges in Scotland. It wasn't an entirely new experience for us, but it was almost entirely new because the staff that we've got who have done this in the past did it in the very old days when BT only started opening up their exchanges. So it's been a steep learning curve, and hopefully I can share some of that with you. So may not be clear to some people what LLU is. Hopefully it is to most people in the room. But ultimately it's unbundling. The local loop unbundling is just putting colo in a telephone exchange building. There's thousands of telephone exchanges across the UK. They're normally within a few miles of most people's homes and businesses. It's where all the infrastructure lives for your phone service and for your broadband service. These are physical buildings. A lot of people sort of don't get that. Cable operators don't seem to have physical buildings. They actually do. They're just fewer of them. Traditional telephone operators have a lot of them. In America, they're known as COs, or central offices. Here, we just call them exchanges, which is confusing because now they're not really exchanges. They're more like data centers. And what that gives you, that presence in that building gives you access, ultimately gives you access to the underlying infrastructure in the ground. So that's copper and fiber last mile loops. It's a physical cable from that exchange building to your customer. There is a new type of LLU which is sort of now becoming a little bit more relevant. It's called subloop unbundling, and that's where you're, rather than taking the loop all the way from the telephone exchange building, which may be several miles away, you're taking the loop just from the cabinet in the street, which is typically, a quarter mile or thereabouts from the customer's premises. And the useful thing there is obviously you can do your own brand of super fast access using technologies like VDSL instead of traditional technologies like ADSL. So there was a bit of an unknown. I didn't actually know when I started doing this presentation how much LLU was out there. I went up and looked up this Ofcom market data research from last year, and it surprised me actually because I assumed that BT, WBC and IPSC based products were the vast majority. It turns out it's not. And I also had a preconception that cable was bigger than it was. Over the last few years, as you can see, LLU's actually become the dominant player. It's got a bigger share now than BT, according to this Ofcom data, and it's still significantly bigger than cable. Obviously, we're now starting to see the trend in the sort of fiber to the cabinet, superfast type technologies creeping in there as well. And that kind of changes things a little bit because there are some people doing LLU to access that, and I'll explain a bit about how that works in a minute. But yeah, it's a big chunk of what the broadband scene is. If you use guys like Sky, if you use guys like TalkTalk, or if your provider uses one of these other networks, the likelihood is you're going through an LLU infrastructure rather than going through the traditional BT infrastructure. So why would an operator want to unbundle an exchange? It's an awfully onerous task, and it's not to be something that you take up on a whim. It's a significant investment and everything else. So there's got to be a good reason to do it. At a global level, what it does is it creates competition. When BT were privatized and everything became regulated, there was a need to allow other people into these exchanges to let them provide something other than what BT was on offer. And from the previous slide, you can now see that that's a pretty mature market. It gives you better control. So if you're unsatisfied, as we were, with what other people were able to do, both in terms of problem solving and things all the way up until the telephone exchange. We weren't comfortable that they were resolving those things quickly enough or fast enough for what our customers were looking for. We're a business ISP, so we've got some very demanding customers. We needed that better control, and a lot of people do it for those reasons. Also, there's a limited amount that you can access. Guys, these huge big operators like BT and TalkTalk and Sky are really catering to mass markets, and they'll put in equipment in that exchange that can only do a certain number of things. And sometimes that's a downfall as well, because it's a sort of one-size-fits-all type piece of kit. They do a good job, but it can't serve everyone, and certainly in the market that we're in with business, we need a bit more than just what's available in the domestic market, or what the domestic equipment's been sort of bent and shaped into making a business product. The other thing that people do unbundling for is to create strategic POPs. So they might not actually be using the exchange to do any LLU, but they need a POP in that city, maybe as an interconnect with BT. There's a lot of voice operators out there who have SS7 interconnects, and they may actually host a rack in a BT exchange because that's where the DSMU site was once upon a time, and that's where they can plug into those networks. There's a handful of people who are doing that now, whereas before it was a lot more complicated. You have to physically run fiber down the street and bury it into a BT exchange to do that. So I figured I'd give some examples of what BT exchanges look like, because you probably pass them every day and don't know it. This is one that we're in Glasgow. This is Glasgow Central. It's actually also attached to a big BT office called Dial House. It's amazing how many exchanges are called Central and how many exchanges are also attached to buildings called Dial House. So watch out for that. There's a lot of repetition. And when you're dealing with postcodes and exchange codes and all sorts of other things, you need to sort of pay attention to the fact that Glasgow Central is not Aberdeen Central and isn't whatever else Central. So that's one of the examples of an older building. I think this is a 20s building. Once upon a time, these places will have been filled with, old women with patch cords plugging people's calls in. Some of them are newer and have never had that. And some of them, are multi-purpose BT buildings that have sort of been turned into, they've been retrofitted as sort of data centers. So that's Glasgow Central. There's a very typical BT style building. It's a sort of 60s or 70s concrete monolith in Edinburgh. That's the Edinburgh Waverley Exchange. There's a nicer one in the centre of Edinburgh called Rose Street. That's, again, really quite an old building that's been turned into a telephone exchange and now turned into a sort of digital hub. There's one in Aberdeen, similar. And this is a bit more of a rural one. This is one that we've unbundled in Aberdeen, which is in the Dice area, and it's out of town a bit. Again, 60s to 70s build, much smaller. There's very little in there. There's, about 10 rows of racks and a room full of old BT kit, and that's about it. This is an example of one which is a very rural exchange. As you can see from the mast, there is the backhaul there for the broadband is a radio link. And this is what I call a shed exchange, because it looks like a garden shed. Now, there's probably not much room in there. Most exchanges do have generators and things, and in that exchange, the vast majority of the space will be taken up by the generator. So there really isn't much scope for unbundling, because if every operator in the country wanted to put a rack in there, there'd be a bit of a problem. So the whole process of unbundling exchanges and dealing with Openreach is a bit of I won't say the word, but you have to get into acronym bingo with Openreach, because they have an acronym for absolutely everything. I loved Nat's post on Twitter earlier with UKNOF bingo. Well, we can add all of these to it, because they're not buzzwords, and I'm certainly not going to ever use these in a sales pitch, but there are loads of acronyms that you need to learn, and they're all really similar in different ways, and it's really easy to get confused. So I'll explain what they are. So the main product for the actual co-location of the space in the exchanges these days is called access locate. It replaces the traditional BT wholesale service that when they first started doing LLU, it was all operated by BT Wholesale. It's now moved into Openreach, and the product's called Access Locate. There's sort of various connectivity products that you could argue are for one thing or the other. I've sort of categorized them as copper LLU, fiber LLU, backhaul, and then there's a couple of sort of odd ones, which is what you might use to interconnect elsewhere onto your own network or to get outside of the exchange. So starting with co-location, the Access Locate products, I believe, has been around for a while, but in the last couple of years, they've upgraded it. Now, LTEC, who are a sort of power distribution company, they are doing the whole rack build, all the equipment that goes in it, and the power distribution, obviously. And it's really nice kit now, actually. They've got this concept of what they call a power base, which is just a sort of basic rack, and that has your power distribution and everything in it. It used to be the case that, I'll show you in a slide in a second, that they separated all these various elements out, and it was quite big and cumbersome. Now they've condensed it all, and the way that you order it, your sort of license fee that you pay as a licensed operator in that exchange is based on the floor space that you use, and depending on how much power you need and how many copper tie pairs and other things that you need will determine how much rack space you take up. Now, these days, you get AC and DC power if you want by standard. The exchanges don't have a main DC supply. DC is individually distributed by the LTEC equipment in your own power base. And depending on whether there's genset capacity in the exchange, you might get some protection or not. At the time of ordering, you get told whether or not there's any genset capacity, so you'll know whether you're at risk of AC going down for any length of time. And if there is that possibility, you can always just order more battery backup, which is part of the product. So this is what the old BT wholesale style stuff looked like. That's kind of just one example that I found where you get this rack with the power distribution in it, and as you can see, it takes up a huge amount of space. And there's a 12 or a 15U rack at the bottom, which BT used for putting fiber splice trays and bits and pieces like that in. Then you get what they would have called CRSUs, or customer rack units, that can sort of cascade as far down as you like, and that's where you would put your own equipment. The old way of doing it was that they assumed that most operators who were wanting to go into exchanges were going to be big, so they would separate out the power base, the HDFs, so the tie pairs, and you'd have dedicated space for that. In fact, in this photo, it doesn't really show that, but there would traditionally be another rack footprint next to you with all the tie pairs in it. And then you've got your own space, and that's completely separated from any of the stuff that BT managed for you. You'd have to put your own UPSs in it if you wanted backup. I think there was at some point a variant of the BT Wholesale product that had UPSs built in. I've seen it once or twice, but most people didn't do that. They managed their own UPSs. The problem with this was that loads of wasted space. So we see footprints and exchanges with loads of unused space. Customers come in and put one rack in and never need it anymore. And there's other people who have multiples of these staggered around exchanges because they've grown and grown and grown, and there's no more room, and they've got to have multiple power distributions scattered all around. So it wasn't really flexible enough for the bigger guys either. This is what the new Access Locate product looks like now. So there's the LTEC racks, and there are these purple racks, which are kind of noticeable when you're wandering around an exchange. I don't think I've ever seen a purple rack before. Well, not like that anyway. They've come up with this slightly more flexible solution where you have, in your first rack, you have the power distribution, the HDFs, and your own customer kit if there's any space left. So it's small enough for guys like us just to take one rack footprint, but it's also flexible enough that you might have a TalkTalk of this world taking 6 racks in a row, with the first rack being full of power, the second rack being full of HDF, and so on. The way that they're building it, so what you get in that rack, in your power base, is the LTEC inverters, you get your batteries, and you get as many HDFs as they can squeeze into the first rack. This is one of our racks, so we've sort of got a fair bit of kit in there, but not a huge amount. At the top, you've got a sort of first, I think, it's probably about 10U, no, not even, that's all the power distribution, and that's presented to you on DC feeds at the front and AC on the back. You get a whole chunk of space to put your own stuff in. As you see in there, we've got fiber and bits and pieces. Then at the bottom, you've got HDFs. Because we're only doing one product, we only sell EFM. We don't have massive HDF space, so we don't have loads of type air blocks. And also, we under-spec'd our batteries. When we didn't realize that the Adva chassis that BT used for the EAD product are so power hungry, so we normally now in newer racks, we've got much more space at the bottom used up with battery strings. And these are like car batteries that are slightly neater than car batteries, but it's just a string of batteries, as you might find in any data center, that they've connected up to the LTEC at the top. So the cool thing about this, you can order it with or without doors. We order ours with doors, and so you get this funky little panel at the top that gives you your power metering. They also meter it by phone line, so I don't know actually why that's there, because we can open the rack and see it. BT, if they need to see how much power we're using, would log into their system to see that. But it's kind of neat nonetheless. The other thing that is on the rack itself is this big yellow ironwork at the top, which has the cable trays that go up to all the runways at the top of the exchange, where all the cables go. Most BT exchanges don't have raised flooring, so it's all overhead, which is kind of important. If you're bringing in loads of type air cables or fiber or power or whatever it is, you've got to have a fair bit of capacity to do that. The other funky thing, I don't know whether you can see it in the photos, you get these little work lights, which are on a flex. So you can press a button and the lights come on in your rack and you can see what you're doing, which is kind of useful because the lighting in BT exchanges isn't great. So this is the power distribution stuff that LTEC put in. It's all AC incoming, but the primary feed outgoing is DC. And this is a standard setup. I mean, the product's really flexible. So if you don't want DC and you want to do your own inverters and do your own thing, you can. This is kind of the default settings, and it suits most people. It certainly suits us. You get a 6-way PDU at the back because BT have to provide a PDU in case you want access to EAD products and things like that. They have a Cisco router that monitors it. It's kind of handy having AC as well because there's normally something that you can't plug into DC. The DC stuff is dual fed, so there's actually 2 inverters in every installation at least, and they give you a 16-way PDU with an A and a B feed off the 2 inverters. So if one of the inverters fails, you've still got a second feed, and we dual feed most of the stuff that can take it. So that's actually really nice because if AC goes down and something happens to one of your inverters, you've actually still got a second feed, and so long as your batteries are still alive, you're fine. So, BT give you this kind of cool goodie bag with, when we were wiring up DC, we sort of thought, where do we buy these connectors? And we were really worried about making sure we had all the right bits, and actually when we got our first rack handed over to us, we were kind of chuffed that you get this plastic box in the rack filled with all the extra fuses and bits and pieces like that, so that was kind of handy. Some tips though, if you're buying DC kit, you can't test it in your own office unless you've got an inverter. So we had to go and buy an inverter for our lab so that we could test the kit, and because we were buying D-slams and things that were only DC fed. And if we wanted to test them in the office before they go to the exchange, we had to be able to power them. So we bought an inverter, and it's actually been really useful because, again, if an inverter fails in an exchange, you can go and chuck it in if you have to. Big warning about DC. Don't touch it. It's sticky. AC, you will naturally reflex, and because it's alternating, you will have an opportunity to let go of it. DC doesn't have that virtue, and so if you touch it, you will stick to it. Luckily, it hasn't happened to any of us yet, but it could. The other thing that we found is that we wired up a few things wrong a few times, and it's worth remembering that they don't use live and neutral. I got a telling off from one of the guys in the office who's an electronic engineer who said, no, it's not live and neutral, it's positive and negative. Live and neutral is for AC, apparently, and positive and negative, even though it's actually a positive/negative 48-volt supply, is the terminology you use when dealing with DC, apparently. Ready reckoner, gray is positive, blue is negative. Don't know why, but that's how it is. If you model them up, you will blow lots of fuses. I modeled them up on our inverter and got the positive and negative on the AC side of our inverter wrong, plugged it into our office, took all the electrics offline in our office, which was really handy. So copper LLU, that's what an HDF looks like. You get this rack mountable unit that takes 300 pair blocks. BT hand over tie pairs in 100 at a time. They are then run along the runways back to the MDF, which is tucked away somewhere else in the exchange, big room with loads and loads of chrome panels or solder wires or whatever they were at the time that the exchange was built. Big gotcha, they don't use Krone tools. They use these weird SID insertion tools. Took us a long time to work out what that was. We eventually bought every single Krone tool in the Comtech catalog and just tried them all. So we found the right one eventually, and there's been a few people on the UKNOF list asking what it was, and I went, aha, we know. There's two types of different tie pairs. Depending on what you're delivering, you can either be doing MPF, which stands for Metallic Path Facility, and that's a direct connection, unfiltered, nothing in between your kit and the customer, apart from the test matrix. And SMPF, which is what traditional broadband is. It means that you still keep the underlying phone line. The WLR bit still works, and that's connected to BT equipment, but you're connecting to the your filter just for ADSL. You have to order the right type of tie pair as well, which is handy. So another big gotcha about tie pairs and all this sort of business, it's a huge amount of record keeping that you need to do, and it can get really messy really quickly, so have a database. We built it into our CRM system that just tracks everything only last week because we were getting sick of dealing with Excel spreadsheets and bits and pieces like that. It's actually been a blessing because we've had orders fail and all sorts of things going wrong, and if we didn't have this, we would have been in a real state. Fiber LLU, this is really only relevant for us because we're a business ISP. Most people probably wouldn't be doing much of this. There's the EAD product, which BT Openreach have. There's a local access version of that, which gives you direct fiber tails in the ground, basically lease line type delivery, Ethernet, 100 meg or gig. They do a 10 meg version, but they priced it higher than the 100 meg, so for whatever reason, they basically should have deprecated it. There's the OSA, which will do 2.5 gig and 10 gig wavelength services. There is now an OSEA that uses Sienna instead of ADVA, and that'll do 40 gig and 100 gig if you want it. I don't know whether many people are going to be using that as exchange access. They might be using it as backhaul, though. And there's also an obscure product called Street Access, which is good for sort of events and mobiles and mobile access and bits and pieces like that, which gives you 100 meg to a street side, street furniture from the exchange. The other thing you can get is GEA. So this is the underlying product that Openreach have for all the super fast stuff. It's also known internally at BT as NGA, which stands for Next Generation Access. It's what BT Infinity is based on, it's what Sky Fiber is based on, it's what all these products that you're getting for super fast access, it's based on the underlying GEA product from Openreach. Despite the vast majority of domestic delivery being PPP based. It's actually Ethernet based up to the exchange. So you've got an interconnect in the exchange, which is a gig, or I think you can get a 10 gig interconnect, and they hand it off as a VLAN. So it's just like an NNI, really. Big gotcha with that. It's not as simple as a normal NNI. BT, if you want it, will give you basically an exchange and a cabinet in a box, and it will ship it to you, and it's huge. And in fact, they might have to ship 2 to you because they both use ECI and Huawei DSLAM. So if you want to do all your interop testing on both, you better get both. They'll lend it to you for a couple of weeks. You can test it against your network, and then when you're happy, you can chuck it back. Backhaul, you've got EBD, which is a wavelength-based product, does a gig or 10 gig. It's kind of limited because there's only so many locations that you can go to. There's a handful of what BT called OHPs, which are the handover points. And you can get from an OHP to an ASN, which is an access serving node. And you can get a gig back from A to B. They tend to be long haul type sort of routes, so you might want to use that as your main core backhaul. But then to get to the exchanges that don't have EBD, you might want to be using EAD or OSA. There's also some legacy products because there isn't yet a 10 gig EAD. You can still get the 10 gig WES. And hopefully, if we kick Openreach a bit harder, at some point we'll have a 10 gig EAD because we're gagging for it. The other big thing is that you're not restricted to in an exchange. They're carrier neutral. You can buy a backhaul from whoever else might be in and around that exchange. So we've got backhauls from SSE, Virgin, Vodafone. There's all manner of other operators. You can cable link to any other one of these operators, just like you might order a cross-connect in a data center. You can do the same thing with Openreach from A to B, or even if your operator's outside in the meet me cable chamber outside the exchange building, that cable link product will allow you to access the fiber that they've got. The other big one that you can do, I don't know quite who uses it, there's a product called BTL, Bulk Transport Link, which is if you are within 25 kilometers, if you have, say, a data center location you want to backhaul all your stuff to, you can, I think it's a passive optical solution that they put in, and you can get up to 16 services across from an OHP site into your data center or external. It could be your office or wherever you like. I don't quite understand it because it takes a full rack. BT require a full rack of space for it. I've read the SIN documents and it's kind of an obscene amount of space that's needed, and it's hugely expensive, so I'm not entirely sure who it's aimed at. Gotchas for you. The onboarding process is heavy, and for every different element that you deal with Openreach, you need a different onboarding process, and there's various requirements for each of them. You need a huge insurance policy. Obviously, if you're going into telephone exchanges and sending your own engineers, you have to have some serious insurance to make sure they can't do anything wrong. And the credit checking is pretty severe as well. BT systems internally, you have huge learning curve in all the different things that are required to get that done. For security, there's various systems. You get access cards and you have to register for them and they post them to you, and there's various certificates you need to get signed and all sorts of other bits and pieces. It's really, really quite complicated. For ordering LLU, there's various systems for that, and Ethernet's a completely different system. They tried to move it to the same system, it failed, so they've brought it back into the old legacy system, which is a Windows fat client, pretty hideous program. There's all sorts of Excel spreadsheets. I cannot tell you the Excel spreadsheets that we have to deal with. And learn your KCIs. KCIs are fun. They are for everything. So if you're ordering a new exchange or you're just ordering an access circuit, you get a KCI. And it stands for Keep Customers Informed. So they're kind of handy, but also the bane of my life. The price list needs to be understood fully. BT don't quote for anything, or not really. They will in some ways, but usually not. So make sure you fully understand what you're ordering, because otherwise you'll get a shock when the bill comes in. Get to know the SIN documents and get to know the Openreach price list. It's all available on their website, and it's actually pretty good. So, any questions? That was easy.
No questions for Charlie? Oh, hang on, Nat.
Hey, Nat Morris. I've got a question. How long does it take from the point of placing the order to you can get into the exchange and put kit in there?
So the process involves a survey that they'll tell you how much power and all sorts of other things that are available. Depending on the availability of the survey engineers, you normally get that back within a couple of months. After that, it will entirely depend on what's required in the exchange to build your rack. So in exchanges that they've got loads of space already and there's previously been customers that have been switching on and everything's kind of lined up, it can be quite quick, 3 months or thereabout. I say quick in Openreach terms, 3 months. There have been issues where we've had, one of the exchanges in Aberdeen that we were in, they had to recover floor space from some old analog audio kit that they used for military circuits or something at some point, and they had no other space to give us, so they had to wait until that kit was removed, and that took another 3 months just to do that. So it varies wildly, but they're pretty good at telling you. And actually, the LLU build team are pretty honest guys, and they're not your typical telco bullshit merchants.
I got second question would be what do you do about access to the exchange? Say you wanted to get in in an hour's time. Can you just rock up at the door with your card? Or?
Yeah, you get a Basel card, and that's my hotel card. That's not it, but it doesn't look much different to a hotel card. It's just an access control, and you got a PIN. And so long as you've been pre-approved, you can get into the exchanges that you've been given access to. You can't just get into any exchange. Some exchanges have keys and things like that have to be pre-arranged, but most of them it's just a card that you get sent. If you lose it, you're stuffed because the systems are so complicated you can't ever reorder it.
Okay, any other questions? Thanks very much, Charlie.